Okay, this video is introducing the idea of being able to solve equations for a line where you may not be able to clearly say where the intercept is. The yellow one we can do straight quite quickly, and we'll do a recap using that one. But the red line, we don't know exactly where it's crossing in here, and the green line, there is no y-intercept. We ignore this intercept. The x-intercept doesn't help us with gradient intercept versions of a line. So the intercept component of the green line is definitely not 5. As a follow-on to that, we will also do a quick note at the end about parallel and perpendicular lines, because the yellow and the green line are parallel. The red line is perpendicular to the other two, and we can see how that relates. It is all to do with direction. Then we'll talk about which component is which when we talk about directions. So first of all, simple one to do first, let's do the analysis of equation, the yellow equation. If we look at it, we know it goes to a point 0, 2. That point on the y-axis is the intercept, and that's my c. And to calculate the gradient, we look at another point that we can find that's on the same line. Because we're looking at gradients, and equations are lying in the form of y equals mx plus c, we worried about the y distance first, and then the x distance. So that was 2 and 1. So my gradient, if you remember the expressions before, is rise over run or rise over right. When we calculate it, the rise is a plus 2, went up, and the right was 1 square. So my gradient is 2. This part said c was 2 as well. So now we have an equation for this line, which is y equals 2x from the gradient plus 2 from the intercept. I'll add it to my diagram. Y equals 2x plus 2. Right, let's look at the second one. Now we've got a problem that we don't know where this point is. We know it's somewhere between 1 and 2, but we can't find it. So the technique we're going to use is we can first calculate the gradient. So the gradient for this one. Need to find 2 points that I can say are definitely on some axes, and it appears to be on the grid. It appears to be that one and that one. So my rise is down 2, and my distance right, the run, is 4 across. So I've done the rise over run, so that simplifies to -1/2. Now this tells me an equation I can, the basic form of the equation, that's y equals -1/2 of x plus my c. And this c value I'm not going to be able to find nicely. This is probably a bit harder than I'd expect for year 9, but it is a technique you need to be aware of. So the second part of this is to find one of the points that I know. The easiest one I can see is this point, which is at 3, 0. So I'm going to use that as my point. 3, 0 gives me my x value and my y value. And I put it into the equation. And this will eliminate the y, it will eliminate the x, and I can calculate c. So we're going to get 0 equals -1/2 of whatever my x value is, 3, add on c. I want the c part on its own, so I'm going to take this expression to the other side. Crossing over the way, let's calculate it first, and this is -1.5. So I'm going to take it to the other side, and that's a 1.5 is equal to c. So that allows me to say my equation is now y equals -1/2 x plus 1.5 in the c direction. As you get more proficient, you're more likely to write this in other forms where this is going to be something like 3/2. As you move it up in maths, we stop writing so many decimals, And we would actually say things like, this is the 3 over 2 from moving that to the other side. So I now have an equation for that line. Y equals minus a half x plus 1.5. And we've got to do the same thing for the green line. So the green line, start off with 2 points that I can find on the axes. I'm going to do them from that point, and I might as well go to that point. I look at the rise, going from left to right. So we start on the leftmost point, and we move right. So my gradient is 6 up, 3 across. So go back to the top, m equals 6 up, 3 across. 6 divided by 3 is 2. So it gives me a basic form of my equation. Y equals 2x plus some value c. And again, I can choose any point. This would be nice to use, but it doesn't matter. It's any point. So I'm going to choose this one, which is 2 minus 6. Put the values in. So 2 minus 6 into this equation gives me minus 6 equals 2 times 2 plus c. If I move this round, this calculates out as 4. I want to take it to the other side or subtract 4 from both sides, and I get minus 6 minus 4, which is minus 10, is equal to c. And that I can write as another little equation as y equals the 2x from above minus 10. And that's y equals 2x minus 10. And if you follow the line down, yeah, if I actually extend this, it comes down 2, we can calculate minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. Yeah, it actually went through the point minus 10 on my axes. Final point on this one. Yellow and red are both parallel. And which part of the equation, y equals mx plus c, sorry, the yellow and green are parallel, talks about direction. Well, the gradient gives you direction, the part in front of the value, in front of the x. So gradient gives direction. If my gradients are the same, they are parallel lines. Okay. The other two lines, you have to think what happens when you turn through 90 degrees. So if I've got a line that goes 2 up, 1 across, to give me this line, when I rotate it through 90 degrees, the instructions change to down 1 and 2 across. That's perpendicular. So the perpendicular line, we have a change in sign. So this first line was m equals 2 over 1. And the perpendicular line, which I'm doing with what looks like an upside down T, it's actually perpendicular lines, is equal to minus 1 over 2. So what you get for the perpendicular is take the gradient, you flip the fraction and change its sign. The change in sign is important because that's what tells it to go from going up to the right to going down to the right. And that gives us perpendicular. Okay, so that's how you can actually find general equations of lines and parallel and perpendicular lines. Parallel and perpendicular is just a little extension. Okay.